Okay, your joyful, awesome, great math teacher here. No, I don't want that. Now, in all seriousness, the last 2 days was just to give you an idea, and I understand it's weird, not important in your life kind of thing, and it isn't. I get it. Okay, but what it was just to give you an idea of certain different specific ways of gathering data from a not a population, a sample from a population. And then some of them were by the randomness of it, in doing it randomly, then maybe this has a better chance of emulating what the population, which is everybody, feels about a certain thing. And it was strange. We got this random little number generator that the book provides. That's just one example of randomly picking people using a specific row or column from that sheet. That's all it was. One way. Okay, and is that sheet used in the world? No, just one that the book provides to give you the idea. Okay, so at least we know that idea is out there. All right, so 9-3 day 1, day 2 notes. Actually, just day 1 today, and then I have my own. That was weird. My own. Let me go back because I don't know what just happened there. Okay, I think we're fine. Okay, I have my own notes that we used back in Algebra 2 back in the day. We're going to actually add to this. So again, back to my idea. Last 2 days, little weird, little strange. Now we're moving on. Okay, that's the data collection from doing a survey, and how do we select these people? Now we have the data. Now, how do we analyze it? And that's really what's going to happen the rest of this situation, and we're going to go from there. So all measures of central tendency are the following things that we're going to have right here that you've seen before. This is grade school stuff, actually. And as bad as your test may have been the previous one, by the way, I curved it. There were 63 gradable points, and I bumped it down to 56. And if that still didn't help you, then you need to improve. And that's all I'm going to say. I'm moving on. We need to do something different than what we're doing. But I just know the clientele that we're dealing with here, all the way back to watch this video and less than half the people do it, and some people haven't made those changes. So it's either going to happen or not. All right, so number 1, median. We know that as middle. Okay, so the first thing, if you remember, thank you. When we got data in the very beginning of January, we took that data, and the very first step was to put it in ascending order. Okay, so that was something we did from day 1, and I can't even remember my altered state of mind right now what we did from there. But that's something that we want to do for the whole year. Put it in ascending order and then go from there. All right, and then do remember as I move in on this, how do you find the median when there's, for instance, an odd amount of numbers? Well, that's easy. The median is actually smack dab in the middle, so it is 4. So what I'm highlighting here in letter A is 4 is the median. And then I don't have to write this formally. When the middle is 2 numbers, then you need to find the average of that. Okay? So ain't no thing, chicken wing. Let's move on. This is stuff from grade school, like I say. Next one is mean, just like your teacher, Mr. Samuelis. Mean means average. Now, what I put over here is you're probably not going to be tested on this now, but just make a note to self. There's that mu again. That means the variable that describes population mean. Okay, so that is back to what I said yesterday, United States of America. Let's pretend there's 300 million people. That's mu. Okay, from those 300 million people, I want to do a survey of, I don't know what would be good. Let's say 1 million. That's X bar. That's the sample that's trying to emulate what the population of the United States are. And then again, piggybacking off with the things we talked about yesterday, how do you select those 1 million people? Well, maybe by demographics, which is one of our example yesterday. 300 million people, 20% are this demographic. Well, then 20% of the million people should be from that same demographic. And that was one simple example that we had there. Okay, and then I'm just going to leave these notes up here. There is one that I will formally write with you that actually last hour told me was not new. Not at all. Okay, so now what's a weighted mean? A perfect example is a grade point average. A's are weighted as a 4 here, except this one's a 5 in this honors class, if we look at our weighted grade point average. But normally, A's are a 4, B's are a 3, C's are a 2, D's are a 1, and then the big fat F is a 0. All right, so points have different levels of importance. That's what a weighted mean is, which is what this example shows you. And then they have a formal, formula for this, which could seem complicated, but it's really not. So, how do you get a weighted grade point average? Not weighted grade point average. How do you get a weighted average, which would be your GPA from this scenario? Well, Sarah gets 2 A's, so the formal writing of this formula is the amount of those times the weight of it. Right, and remember that for your formula when it's not necessarily a grade point average question in your book. 2 B's that have a weight of 3. 3 C's that have a weight of 2. So you actually multiply those. And then you divide that by how many occurrences total. I had 2 A's, 2 B's, and 3 C's. So how many occurrences of those? And then you end up with your weighted mean, weighted grade point average, which is not weighted. Keep saying that, but all right. So anyway, I think that should be self-explanatory how to get a weighted mean. No problems there. All right, and then mode, most. I don't know if I could say anything else about that. I asked last hour, what's mode? And only one person knew it was most. So most commonly occurring value is the mode. Okay. Now, here's a more formal definition about the skewed and why we say skewed left and skewed right on some of the data. Okay, so number 1. Again, histograms. Same old, same drawing. But now a more specific definition why we say skewed left and skewed right. Well, looking at these, first of all, look at that variable. Gosh, dog it, stupid computer. Okay. Mu. Mu is the population parameter, population mean. When the mean is actually equal to the median, then you would get a symmetric histogram. This is actually called a normal distribution, which is something we're going to really hit a lot because a lot of things in nature and in life are normally distributed, so then we can analyze it from there. But anyway, look at the mean equals the median. Now we could really look at what skewed left means, which now I have it memorized. When more of the data is on the right, it's skewed left. Not really a big deal. What ends up happening with the data when it's more on the right, the mean is actually left of the median. So that's where the word skewed left comes from, because they're talking about where's the mean compared to the middle. And the mean is left of the middle. So that's where the word skewed left comes from. That's the first time I said that correctly. And then, of course, when more of the data is on the left, it is skewed right. That's because the mean would be right of the median. All right? So give you a chance to write those down. Those are just formal definitions that you need to memorize. What does he know? Gives info about how the data varies from the middle. Okay? And then these notes are only going to be like 10 minutes. And then to actually ask you to do homework after this and actually practice it right after that in the time that I allow you. How many people I see don't do that is a slap in the face as well. So, just tired of getting slapped in the face. I'm bruised. I'm bleeding. especially after that test that I just graded. So what's the range? We already had that before. I think that's when we started off this semester, when we ordered the stuff in order from smallest to largest. And then one of the things was find the range of the data. And that's subtracting the max minus the min in that order. Now what we're going to get into is our formal example of cutting up the data into quarters, which is actually what we're going to do next. That's why we were going to have quartiles. Okay, so quartiles, the median's in the center. Okay, that's actually going to be called quartile 2, and we'll put that later, so don't write that down yet. So we're going to arrange the data in quartiles because we like to see where's 25% of the data, where's 50, where's 75, where's 100. Then actually tomorrow's notes we're going to expound on this and add the idea of outliers. Okay? So, use when median is at the center. So we're going to arrange the data from least to greatest. The example that we have today already does that. You're going to find the median, which actually is called quartile 2. It is also called the 50th percentile. That is because 50% of data is above and below the 50th percentile. Now, when we talk about 25%, 25th percentile, which is Q1, 25% of the data only is below it. 75% is above it. But that's what that means when you're at that percentile. Then we'll cover other percentiles tomorrow, like what's the 60th percentile, which when we did like ogive graphs earlier in the year, that's when they were talking about percentiles of where the data falls. And the 60th percentile, as I'm blabbering on as you write, 60% of the data is below the 60th percentile in the arrangement of numbers. But anyway, okay, now again, the words, I've told you all year long, the words are just there for a map. When we actually do it, it will make more sense. But after we find the median, we will have to find the quartiles 1 and 3. Q1, if you want to see where I'm talking about, is the 25th percentile. It is the first quartile, and all it is the median of the first half. And I think this is something you've done before. Is that correct? Have you seen this before? I think this is a Math 3 or a Math 2 concept. Whereas Q3, remember the median cuts the data into two halves. Q3 is the median. That's what that little, learn to take notes. That means median of, repeated the last word, upper, and then half. So what we want to do is find those two, and then that's the beginning of cutting this into 25% of the data. 25, 50, 75, 100. We'll write our 5-number summary. That means we'll write what is the minimum, what is Q1, what is the median, which is often called Q2, what is the quartile 3, and then what is the maximum. And then the fifth thing is, actually what we're going to make is what's called a box and whisker plot. Sometimes it's called a box plot, but it's a box and whisker to help see this data. Okay, is that good enough? Anyone still writing the words? That's fine if you are. I know I'm the evil ogre right now. Good? Going once, going twice? No one talked to me? All right, let's move on. Okay, here we go. Results from a discrete test. By the way, is there an outlier? By the way, has Mr. Samuelis witnessed this year? Yes! It's not good. And it's actually unacceptable, and I don't know what to do about it. But the horse water thing. I just don't know what to say anymore. Okay, in this 3 months that we have left together, some people can make different decisions, and we're here for 51 minutes. Maximize them. Some people don't do that. But anyway, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I have 17 numbers. What number is the median? Not the specific number. What number in the list is the median if I have 17 numbers? Number what? Not number 3? The what number? The 5th number, the 6th number, the 10th, 9th, 8th, hike. 1, 2, 3, 4, 5, 6, 7, 8, 9. Did I do that right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now I have a distinction to make here. Okay, this is easy. All right, I am going to label this as the median. By the way, what's the mode? You don't need mode for a box and whisker, but what is the mode? 63 looks like it happens 3 times. 84 is close, but not quite. So the median is 63, which is also called Q2. Now, pay attention. The only thing you could screw up on this. When I have an odd amount of numbers to start off with, and the median is exactly 1 number, then in order to find Q1, you ignore that number and group these as the first half of the list. Okay, because that's right in the middle. If this is like a pyramid, that number's here, then all the rest of the numbers stack left and right of it. I don't know how else to explain that. That is the truth. So when the median stands alone by itself, to find Q1 and Q3, you ignore it. Right? Then also look, when the median is, when there's an odd amount of numbers, there's an even amount of numbers left over for Q1 and Q3. So the lists are equal. But that's neither here nor there. If you didn't do that, then you'd have to count this 63 in this list and this list, and that's what's wrong. You don't do that because that's you're double counting that number in a way, and it skews that a little bit. So anyway, 1, 2, 3, 4, 5, 6, 7, 8. What's the median of this first half? Well, this one I have to incorporate 2 numbers because that represents the middle. So what is the median of this first list? What is that answer without having to write it out because we don't need that math? You should know it's 56 quite easily. Call that Q1 and this is 56. And then the same thing on this one. You should have the same amount of numbers in this list. If there's 8 in the first half, there should be 8 in the second half. Otherwise, you don't have half. Okay, so what's the median of that? Just a little bit of mathematical prowess here. We'll get this taken care of. What's the answer? 79.5 is in between 78 and 81 perfectly. Okay, so then what did I say? Hey, write that 5-number summary. We're almost done. You don't have to listen to my voice anymore. You get a break after this, after the turn into the Hulk without the muscles or the turning green. What's the minimum? What's the minimum? 6. What's Q1? We already got it. 56. Call this the median. The middle of the data, what's that? 63. Q3. 79.5. And then the max is 93. By the way, we call 6 outlier. There certainly could be an outlier on the other end of the list. Imagine a discrete test where we have 100, 98, then the next highest grade is a 60, then a 58, and then so the outliers could be on the other end, and that would say something about the test possibly, but we'll just leave it at that. Okay, now how do you graph it? You can actually do a box and whisker plot on your graphing calculator, which implies that we do have a number line that we have to account for. And actually, let me do this better than I did last hour, meaning I think it's better if I do this. And let me just do, well, I do want a line though. Okay, so I'll do what I did last hour. Okay, so 0. Tests go up to 100. Half of that is 50. What you need is scale and nice little spacing. But this is where I run into a problem because halfway between 0 and 50 is 25, and I really want to go by 10. So I try to make 20 there and 30 there. 40, 10, 10, 20, 30, 40. And then same thing, this is about 75 right here. So 70 is a little bit that way, and 80 is a little bit that way. Just trying to give you an idea of how to make this look at least spatially good. And the spacing is somewhat even. I don't think I did a bad job there. Okay, so the standard box and whisker plot. Best thing to do is to start off with the median. So I'm going to do that in green just to have that stand out. So the median is at 63, approximately right here. You draw a line. That's going to be the middle of the box. We're going to have a box here in the middle that connects Q1 to Q3. Next thing, either one, Q1 or Q3, 79.5. Ain't no rocket science, ain't no big deal. This is one of your boxes. Shaky, shaky. Okay, and then you should be labeling these. Median is just a standard M. Q3 is this. We just put a Q3 above that so the looker at this graph knows what's going on. And then 56. That's right, cha. Then we want to put a Q1 there. For the median, you could also put Q2, but usually you put an M for median. The 93 is here. Okay, now this is why they call it a box and whisker. This is called the whisker. All right, and they make it look like that. Don't know why. Someone made a decision all the way back in the day. All right, and then we got to go all the way back to this outlier. Tomorrow, we're going to call an outlier what it is. We're going to find a mathematical way to determine outliers. But I think everyone knows when we have a 44%, then it skips all the way down to a 6. 6 is an outlier for sure. All right, and then we could call these mins and maxes, but they usually aren't. They're known as this. So notice the data, the lower 25%, there's quite a big spread, and that's what this means. So when we look at this, I don't know what color that is. Is that black? This represents 25% of the data. This approximately. Again, when we have to maybe split up the median because it's an average of 2, this is approximately 25% of the data fits in these quartiles. And that's what you do. You're just organizing the data in a little graphic that makes it so we can see how the grouping of the numbers are. So that's what stats does when we talk about standard deviations and all this other stuff. It's how is the data grouped, how is it spread out, how tightly packed is it, so on and so on and so forth. One more thing, I know you want to get done here. Let me give you one more list and just make a point of this. 2, 7, 9, 11, 15, 25, 30, I lost track. 1, 2, 3, 4, 5, 6, 7, 31. I don't know. Here's a grouping of data. Just wanted to make this point, and it's only one point. We're not going to do everything for this. Just focus on one more easy concept. First of all, I have 8 values. So to find the median, first of all, what is the median? It's just 13, the average of 11 and 15, actually right in between. But now to find Q1, remember in the last example when the median was one number? When the median was one number, we ignored it to find Q1 and Q3. Because exactly half the data is before and half is after 63. Here, now we have to draw a line. And then this is what I need to use for finding Q1. So when the median has to be found by the average of 2 numbers, those 2 numbers are actually still used to find Q1 and Q3. Okay? So again, hopefully you're paying attention to that. By the way, what is Q1 then? 8. And then what is Q3 if you can go ahead of me here? Yeah, we got that decimal again. Okay, so just a note to self. All right, trying to help you with any scenario that you might run into. 27.5, right? Okay, just an idea. All right. So when the median has to be found by two numbers, those two numbers are actually still in the list for Q1 and Q3. Not the case when the median is one specific number. It's ignored when you're trying to find Q1 and Q3. All right? So hopefully we get that. All right, I'm done. I'm just going to stamp up here and leave you alone. If I see one guy